We're extremely fortunate to have with us a fabulous engineer and visionary to talk about a very important subject, and that is the future of the automobile and the future of transportation, a subject which commands our attention because of the impact of transport and the automobile on every aspect of quality of life and the physical environment, energy security, climate change, and all other aspects of sustainability. And I know of nobody who can discuss this in a more holistic and thoughtful and detailed way than our speaker tonight, Larry Burns. Larry Burns was for 11 years Vice President of General Motors for Research and Development and Strategic Planning. And in that capacity, pushed inside General Motors for many crucial innovations which are now coming onto line, including his leadership on the Chevy Volt, which will be, I saw it myself when I visited Larry a few weeks ago and his team, which will be coming off the assembly line next year and into the market, and will be a breakthrough of the plug-in hybrid. But what you're going to hear tonight is a really remarkable systems vision of integrating the automobile technology with new energy systems and energy delivery with information and communications technologies and all that can entail and make possible. This meshing of sustainable energy, sustainable transport, and information and communications technology is the subject of a forthcoming book of Larry's, which is absolutely wonderful, called Reinventing the Automobile, which will be published at the end of the year by MIT Press. He is trained as a civil engineer with a PhD in civil engineering from University of California at Berkeley. He's a full-fledged systems thinker. He's been on the front lines of automotive technology like nobody else, and it's really a great pleasure and honor to have you here. I'm very excited, and I know it's going to be a treat for everybody. Larry.
Thank you very much, Jeff. Can you hear me okay in the back? Yeah, you know, that's really important to me. I lost my hearing 15 years ago, so I hear with a special technology called a cochlear implant. And by definition, it makes me an optimistic technologist because I am able to function pretty well with that technology. I had an interesting moment. Recently, I was at my audiologist, and I happened to leave with 2 other patients that had the same technology. And the person next to me, we walked outside, and she said, "Isn't it windy?" And the guy next to her said, "No, it's Thursday." And I said, "So am I, let's go get a beer." So it worked out pretty well. This is a very exciting moment for me because this is the first presentation I've given publicly since I left General Motors at the end of September. I was with GM for 40 years, and it was an exciting 40-year period, but it was pretty tough, quite honestly, the last 3 or 4 years with what's going on in the economy. I sort of felt like I've gone 15 rounds of boxing, and one thing I learned is the toughest thing about boxing is picking up your teeth with your boxing gloves on. And it's been that brutal, quite honestly. And so when I left, a lot of people said, "What are you going to do next?" And I decided to consult a great visionary, Yogi Berra. And when they asked Yogi Berra what he was going to do when he retired, he said he's going to finish his book. And they said, "Oh, you're writing a book?" And he goes, "No, I'm reading one." But we did get this book finished. What I'm going to do today is take you through a vision for personal urban mobility. I'm also going to talk to you about a concept that I call the power of and, which is really distinct from or, the power of systems thinking. But first I want to give you a flavor of what's behind all of this. This is a vehicle that we revealed here in New York City last April. General Motors is going to be the exclusive automotive sponsor in the Shanghai Expo, which starts this May. And as a result, we wanted to paint a picture of what might be possible in the year 2030. And we teamed with Segway. And many of you know about a Segway. It's a two-wheel balanced machine. But the challenge of a Segway is you're traveling alone, you're standing up, you're exposed to the weather, and you're limited to 12 miles an hour. We felt travel was a social interaction, so we wanted more than one person traveling. And we felt it needed to go a little faster than 12, and people wanted to be protected from the weather. This obviously is a design property. It's not a final design. I'll show you those designs in a minute. This vehicle will go 35 miles on a single charge of electricity, 3 kilowatt hours. To put that in perspective, the Volt is, let me just, a 16 kilowatt hour battery. So it's 1/5 the amount of battery, but you can go essentially the same distance with a top speed of 35 miles an hour. And you can park 5 of these in the same amount of space it takes to park a car. And for people who have been following this whole energy consumption in cities associated with cars, many places, Manhattan included, you find that about 20% of the energy is people looking for a place to park. So we felt we needed to do something transformational, and the challenges are enormous. So here's what we're going to talk about: the electrification of the car, recognizing that for 100 years the car has been primarily a mechanical machine. Connected vehicles. I'm talking about vehicles that speak with each other and with things along the roadway, and contrast to standalone vehicles that we drive and control pretty much independent of each other. I'm going to talk about a new automotive DNA, a new design genetic makeup that allows us to create designs that are dramatically different than what we've known. I'm also going to talk about urbanization, because today more than half the people in the world live in cities. And when you marry urbanization up with electrification, there's some exciting opportunities around smart grids and around charging infrastructure. And when you marry it up with connectivity, there's a concept that we've coined a mobility internet, which will be for automobiles what the internet was for your laptop computer. And then this real-time information allows us to use dynamic pricing for roadway space or congestion pricing, for parking, and also for shared vehicle use and for energy. And when you pull all that together, we're talking about reinventing personal urban mobility. I'm going to tell you that these products will have a total cost, energy cost, purchase cost, maintenance cost, parking cost, tolls, and other things, 1/5 that of a conventional automobile on a per mile basis. So we're also dealing with equality of access. I'm going to try to convince you that these cars won't run into each other. They won't crash. And so we're going to deal with congestion and safety challenges. And all of this really is motivated by the fact that automobiles are important to people. And you ask, why are there 850 million automobiles in the world, 250 million here in the United States? What is it that's driven that huge growth? And why, when emerging markets begin to grow middle classes, one of the first aspirational products people want is an automobile? It's all about the freedom to go where you want to, when you want to, with the people you want to travel with, carrying what you would like to travel, like to take with you. Now, we'd like to take that freedom to a new plateau, because there's other kinds of freedom that we're experiencing, the freedom to connect socially, social interaction with handheld devices. And we know now that when we text, message, and drive, it's a pretty risky thing to do. In fact, we've become convinced that driving is the distraction, because anyone who would send a text message when they're driving is concluding that maybe that's more important than safe driving. Is there a technology solution to that? But in order to have those freedoms, we have to do it sustainably. And we're talking about sustainability in terms of energy, environment, safety, and affordability, but also in the case of urban mobility, congestion, and parking. I was fascinated as I was preparing for my trip here today and reading some of the literature about Columbia and about your master's in public administration program focused on environmental science. You have a paragraph in there: the realization that institutional, social, and economic processes interconnect to both sustain and endanger the planet, and the need for professionals who can maintain the health of this interconnected system. That's pretty exciting, because you're talking about the interconnected system within which these externalities exist, but also within which we pursue these freedoms to move around and interact. So let's start with some key megatrends. First, population. The chart might be a little bit hard to read, but this is just basically rural and urban population, and you can see in 2007 the lines crossed. So at that point in time, more people began living in cities than outside of cities. Interestingly, the demographers are predicting that by around 2025, 2030 timeframe, 80% of the wealth in the world will be concentrated in cities. So if you're in the auto industry and you want to sell cars to people, you're going to sell cars to people who have the economic means to buy it. And if those people are concentrated in cities, you can't not look at what's going on with urbanization and not be prepared. Now let's look at another aspect of that. Developing cities are the most densely populated. This is sort of a spatial representation of London's population, New York's population. Obviously Manhattan is in the middle of that. But look at Shanghai. And we're seeing that kind of population density many places around the world. And this is just a bar chart. It's not all of the cities. The red are U.S. cities. The green are Latin America, yellow is Europe, and very importantly, blue is Asian cities. And look at these population densities, and look at where Manhattan is relative to some of the larger ones, but New York in total. And what we're seeing is an enormous growth in the number of cities with very dense populations and very large populations. Now, one of the externalities of the automobile are roadway fatalities. And this happens to plot the traffic fatalities. These are people who are pedestrians, people who are on two-wheelers, and people who are on automobiles. So clearly, not all of the fatalities are automobile fatalities the way we might think about them primarily. Other nations, there's a predominant number of more vulnerable people using the roadway. 1.2 million people a year die on roadways. That's epidemic in scale, without question. And we need to do something about that. So automobile growth, you could argue, could be constrained by energy issues. It could be constrained by global climate change issues. It could be constrained because the value proposition is compromised because you can't go where you want to when you want to because there's too much congestion, or it could be constrained because just too many people are being harmed by automobiles. From a consumer perspective, it can also be constrained simply because it's not convenient any longer. This chart plots, it's a little bit busy, but it's the percent of people who own 0 vehicles, 1, 2, or 3 or more vehicles in different parts of New York City. So look at Manhattan, and not surprisingly, about 80% of the people in Manhattan do not own a car. And it's pretty obvious why. It's expensive to park, and even when you're driving around in it, you don't get around fast enough to really have a big advantage, and you have a good alternative to the car. But look at out here in Staten Island. It's only 18% that do not have a car. But if you're really paying attention to where the wealth is going and where the population growth is going, you have to conclude that a lot of these extrapolations in the growth of the global automobile park may not come true. In fact, we did an analysis and we asked ourselves if China's automobile population and Shanghai specifically continues to grow at the rate that it has the last 10 years, by the year 2025, all of the land in Shanghai will be covered with cars. It's not going to happen. And so it really motivates us to think about alternative solutions. There's a clear message being sent to all of us relative to how we're moving around and interacting, and it's a very exciting one, and cities are stepping up to that. Here's Singapore with road pricing, and then in Bogota, some rail transit systems, bus rail transit systems, and in Paris, bike sharing, and here in New York City, dedicated bicycle lanes. The fact is, cities are beginning to act like nation states. It's driven by the rapid growth and congestion, by broad resistance to urban highway construction and challenges with public transit financing. And very, very importantly, cities are going to be competing with each other and already are marketing themselves for quality of life. And that quality of life has to deal with these externalities of the automobile. So now we're really into some exciting options. And it kind of reminds me of the story of a physicist and a physician and a politician were debating which profession was the oldest. And the physician said, well, obviously, when life was created, that was a medical miracle, so the physician had to be here when that happened. And the physicist said, yeah, but how do you think order emerged from all the chaos that allowed that life to happen? And the politician said, who do you think created all the chaos? And where I'm going is, yes, this is great that cities are going to act like nation states, but is there something better we can do than just a political solution? And what's very exciting about that is this new DNA for the automobile. 100 years ago, the automobile industry started to grow dramatically, not just in the United States, but Europe and elsewhere in the world. And it grew with a mechanically driven machine, powered by an internal combustion engine, energized by petroleum, which was mechanically controlled and hydraulically controlled in standalone operation. And over this 100 years, the vehicle has become safer, has become cleaner, has become more efficient, dramatically more affordable. But if 100 years from now you dug up a car from a 1900 period and you dug up a car from the 2000 period, you would claim they're genetically the same. And we think that DNA is about to shift dramatically to electrically driven vehicles that are powered by electric motors, energized by electricity and hydrogen. I'm going to emphasize that word, and electronically controlled, and very importantly, electronically interconnected. And what I want to do now is go through some charts about this that help you understand why this new DNA offers so much promise, especially in urban areas. But first, let's talk about automobile consumers. There's really two kinds of cycles out there, a driving cycle and a duty cycle, that differentiate the kind of car or truck you might decide to buy. Driving cycles go from stop and go, so certainly in a city and a place like Manhattan, a lot of stop and go, all the way to continuous driving. If you have a long commute driving on an interstate, you're driving continuously. And loads can be very light. I'm just moving myself. Too much heavier. I'm moving myself, my two dogs, my mother-in-law, my two daughters, to other people moving freight or moving things that they use for part of their job. So when you look at that whole space and you ask yourself, what's the potential of electrically driven vehicles, the answer isn't one thing. There certainly is an opportunity, and I shifted those scales over here to this corner. There's an opportunity in cities for pure battery electric vehicles. And if you then have a little bit more than city driving requirements, maybe you could have an extended range electric vehicle like the Chevrolet Volt. I'm going to talk about that in a slide or two, but it's essentially a vehicle that goes 40 miles on a single charge of electricity. If you have to go more than that, an engine kicks on and generates electricity and extends your range. But if what you're looking for is family-size functionality, fast refueling, 5 to 8 minutes, a 300 to 400 mile range between refueling, fuel cell electric vehicles look very promising. And beyond that, advanced diesels, cleaner diesels for moving freight between cities are very, very important. The point that I'm making here is all of this technology is important. Later in the talk, I'll emphasize how synergistic it is. Let me talk about the Chevrolet Volt just for a minute. This vehicle will be in the market in the fall of 2010. It is using advanced lithium-ion battery technology. Now, the auto industry has used lead-acid batteries or used nickel metal hydride batteries, and while they began to start a movement toward electric vehicles, they just didn't have the energy density and the power density to meet customer requirements to drive large-scale adaptation. The general sense is the lithium-ion technology, which isn't one technology, it's a general class of technology where lithium is an ion that's carrying an electron back and forth. But that general class of battery technology, as it matures, has the promise to come much closer to meeting consumer requirements. Not everybody, but a large enough market to really make a difference. Now, we learned from the EV1 that people do worry about their range. If they're driving along and suddenly they realize they only have 10 miles of battery electric range left, you start to get worried about getting stranded. And we didn't think we could bring out another electric vehicle that had that range anxiety, so he said, what do we do about that? Well, let's do an electric vehicle, put a range extender on it, so essentially we have an engine and generator, and when your battery charge gets low, it kicks on and generates electricity, and you can keep driving electrically. Pretty exciting. So this is truly an electric vehicle. The battery is 6'9" and weighs 390 pounds. That's the size of an offensive lineman. And the amount of energy that you're going to use with that battery, each charge is equivalent to 40 miles of driving range. this same size vehicle will go 40 miles on 1 gallon of gasoline. So if you're wondering where is this energy density of these batteries, what's lithium ion helping us do? Compare an offensive lineman to 1 gallon of gasoline, and those are the energy equivalents. So yes, the batteries have improved, and yes, 70 to 80% of the people drive less than 40 miles a day. But that's a lot of battery. But you know, we're never going to realize that potential unless we get started, and this is a great way to get started. The customers are going to be thrilled with the Volt. Great acceleration, great performance, it looks great. They're going to have a customer experience that really is differentiated. And we're going to begin to learn about automotive lithium-ion batteries at a scale that stimulates a supply base that kicks off a learning dynamic from Gen 1, Gen 2, Gen 3, and ultimately gets us to a point where this is going to make a difference. Now let's talk about fuel cells. A lot of people like to think it's either batteries or fuel cells. I'm going to emphasize over and over tonight, it's both. They are very different and very complementary. But a fuel cell is nothing more than a battery that provides electricity as long as you have hydrogen stored on board. And both GM and Toyota have demonstrated fuel cell vehicles that can go 350 to 450 miles on a single tank of hydrogen. And that's pretty exciting because the refill of that hydrogen is 5 to 8 minutes. And we're talking about a Highlander-sized Toyota, and then for General Motors, it's a Chevy Traverse, full-size family crossover SUV. And their energy equivalents using the fuel cell are on the order of 50 to 65 mile per gallon equivalent with the fuel cell and the hydrogen. So this is important. It's more than twice as efficient as an internal combustion engine, promises comparable precious metal content as a catalytic converter, suggests we can make this affordable, promises equivalent durability, range, and performance, 60% fewer part numbers, and 90% fewer moving parts in an internal combustion engine. So for the engineers in here, how many of you are engineers? Okay, for you, you understand that the movement of parts relative to each other is where friction occurs, where heat builds up, where corrosion happens, where tolerances stack up. You really have to get that right. And if you reduce moving parts by 90%, it's dramatic in terms of being transformational. So both of these are important. GM built 115 of these vehicles, and we've deployed them with regular families so they can have a 2 to 3 month experience of using a fuel cell vehicle as part of their everyday household fleet of cars. We now are over 1 million miles of hands-on driving experience in real world. We've had 10,000 fill-ups of hydrogen, and we've trained first responders. Several of these vehicles are over 20,000 miles and improved quality, reliability, and durability. The point I'm making with this slide is this technology is real. A lot of people argue, well, where's the hydrogen going to come from and the hydrogen infrastructure? Those are really solvable challenges in the scale of what's going on. I don't have time to dive into that. Maybe we can in Q&A, but we think this is an important part of the technology. Okay, now what we want to do is take the next part of this and solution, and that's cars that don't crash. I mentioned 1.2 million people a year. In the United States alone, there's 43,000 people in car crashes a year. Now, some people think the answer is make our seats out of Velcro and require everybody to wear really fuzzy clothes, and you're going to stay safe in your car. We actually think the answer is to prevent the crash altogether. And you might say, well, this guy's dreaming a little bit about this. And in fact, I think I can make a case that it's possible. First of all, for cars to drive themselves autonomously, you need to know where you are, and GPS systems and digital maps are giving you a very, very rich ability to do that. You need to know what's around you, and that's 360-degree sensing. And I'm going to talk about a sensor called vehicle-to-vehicle communications. Then you need to be taken to where you want to go, and that's software algorithms and electronic controls and actuators. And in fact, I feel so strongly that this technology is coming together on autonomous driving, that the technology roadmap's coming together probably in 5 years, that the real limiting factor for the world to benefit from it will be liability and privacy issues. So how many of you are lawyers? Okay, so the lawyers are going to have a lot to say about this, a whole lot. And it reminds me of a funny story about there was these 4 lawyers who had to measure the height of a flagpole as part of a court case. So they get their ladder and they go out with their tape measure and they climb on the ladder. They couldn't reach the top, so they get on each other's shoulders. They're falling down. A big mess is taking place. And an engineer comes along and says, I think I can help. And he pulls the flag out of the ground and lays it flat, takes a tape measure and measures it end to end, and says, it's 20 feet tall, and walks away. And the one lawyer goes, those engineers, we needed to know the height, and he gave us the length. So the point here is you're going to need both. You're going to need the technology, and you're going to need to have the social and political systems to deal with realizing these opportunities. Now, how far-fetched is this really? GM has a product called OnStar, and hopefully some of you have heard of OnStar. It's a telematics-based system. Every car has GPS and wireless communications. It's tied to satellites, and satellites are tied to call centers, and we can give our customers a whole host of benefits as a result of that. So if you get in a crash and your airbag deploys, instantly is known by the people in the call center, and they can dispatch emergency help, for example. There's 6 million OnStar subscribers. We've married up that capability with stability control. Now, stability control is a technology where we're looking at the wheel speeds of a vehicle, how fast are the wheels spinning, and we're also looking at the steering inputs. And we reasoned if we knew where two cars are through GPS, we could calculate how close they are to each other within a meter. And if we knew the wheel speeds and steering inputs, we could determine where they're going to be in the next 20 milliseconds. And we could know whether they're going to run into each other, and if they were going to do that, we could prevent that from happening. So that's what vehicle-to-vehicle communications is all about. And the game plan then is to have an embedded device about the size of a BlackBerry or an iPhone that acts as a transponder. So it could be embedded in a new car, it could be standalone, implemented into an existing car, retrofitted. It could be something you carry as a pedestrian, sending out a signal, I'm a pedestrian and this is where I am, or a bicyclist. And this isn't fiction. I've actually driven these cars with pedestrians holding these transponders, and as I approached the pedestrian, my seat vibrated, my lights flashed, and a voice said, attention pedestrian. And so this technology is moving forward very quickly. Now, it's even moving forward in a more exciting way for the car to literally drive itself. And this vehicle is an engineer's dream. By the way, an engineer is someone who likes to work with numbers but doesn't have the personality to be an accountant. Now, I'm an engineer, and I don't mean to pick on you. Turns out there's two kinds of engineers. Introverted engineers look at their shoes when they talk to you. Extroverted engineers look at your shoes when they talk to you. So, this is an engineer's dream. This vehicle is called Boss. Boss was the nickname of the founder of GM Research. And we teamed with Carnegie Mellon, and we entered a race called the DARPA Urban Challenge. DARPA is the Defense Advanced Research Projects Agency. They wanted a vehicle that could drive itself in an urban setting. And they put $2 million first prize out there. Now, we entered because we needed the money because we were running out of cash at GM. So we were trying to win this race. 85 teams entered the race. So it's not just me that believes these cars can drive themselves. There's 85 teams of companies and universities that teamed up to try to win this. 35 of these vehicles passed the driver's training test, just like the driver's training test you take. Stop precisely on white lines, stay in the lane, manage your speed, parallel park, all of that. 35 of them passed that test. 11 made it to the qualifying final race. And on race day in Victorville, California, there was a military base that was being closed, and they had a urban environment, basically, buildings and streets. We deployed the 11 finalists and 21 real cars, and we had to go 60 miles in less than 6 hours and obey all the traffic laws. About 30 minutes into the race, not our vehicle, but one of the competitors left the road and ran into a house. I don't want you to think this is fail-safe. Boss won that race. And Boss won it and beat Carnegie Mellon, beat Stanford and Volkswagen by 20 minutes. Now, our Boss, we figured we were going to have to stop and start a lot in this driving test, so we really stopped aggressively and accelerated aggressively. You would characterize this vehicle as an X-game competitor. Stanford and Volkswagen had the most graceful, beautiful car you could imagine. Precisely stayed in the lines, gradually stopped, gradually accelerated. They were like a figure skater. But the difference in our vehicle and theirs was 6 minutes alone just by being aggressive that way. Now let me show you Boss in action. Nobody is driving this car. It's like a ghost is driving it. Remote control, no remote control at all. This car is totally driving itself. And again, the race was for 60 miles in less than 6 hours and obey all traffic laws. So the technology exists. I asked the head of DARPA afterwards, what's our next race? And he said, mission accomplished. You've shown us, by the way, 4 teams finished the race of those 11. And this vehicle happened to win. So that was pretty exciting proof point on what that technology can do. So where are we headed with this? This vehicle-to-vehicle communication sensor right here is doing a 360-degree span. That BlackBerry-sized device will probably cost somewhere between 50 and 80 bucks. So it's something that you could retrofit onto an existing car. Costs much less than oftentimes your license plate costs each year. You can have some short-range radars to do some additional sensing on forward collision warning and maybe some ultrasonic sensors, but we've simplified BOSS dramatically and affordably to give us that capability. And then what we're embarking on is a series of what we call precursor applications: lane change assist, lane keeping, side blind zone detection. There's a long list, so I won't read the whole thing. All of these things are already being marketed as individual options on cars, not just by General Motors, but by a lot of auto companies. You could call those market footholds. As we bring them together, we're going to get enhanced collision avoidance, and we're going to get freeway limited autonomous driving. After all, when you drive on the freeway, you need to do 3 things. Keep your car in its lane, manage the spacing between you and the car in front of you, and react if something unusual jumps in front of your car. That's lane keeping, adaptive cruise control, and forward collision warning. Already are on cars today. So we're making some exciting progress there. Now, congestion results from a lot of sources. It can be bottlenecks, it can be traffic incidences, work zones, bad weather. Really, the key to radically shifting the nature of congestion is what we're calling the mobility internet. And I made this point about people using a lot of gasoline to find a place to park. So the mobility internet is really, I believe, the next big thing in information technology. The internet moves a lot of bits of information around, huge amounts of traffic of information, much, much more than any of us experience individually, because we've got systems to filter most of that traffic out. Companies like Cisco have found ways to manage that traffic. The mobility internet is not only going to be managing the movements of bits of information, but they'll be managing the movement of atoms, us moving around and cars moving around, to try to bring real value to consumers. And that's important because travel time is a very, very big driver of our behavior. So when you talk to customers about their automobile, this whole notion of, I would like to get from A to B in a predictable amount of time fast is very important. Because of traffic congestion, a lot of people have to buffer their trips. So I'm going to leave early and get there early, even though I don't need to get there early, but I can't be sure how long it's going to take. So your actual travel time isn't just how much time you're traveling, it's how much time you've scheduled in order to get to your destination on time. We believe the use of real-time information about where vehicles are in real time allows us to understand the state of the congestion in the roadway network and gives us the potential to actually give you a space-time path through the city in advance, and allows you then to have much greater predictability and allows society to realize much smoother flowing traffic. Now, where might that head? This is an animation of these cars communicating with each other, vehicle-to-vehicle communication. You can see here the person in the car is doing exactly what they want to do with their time. This next moment is pretty exciting. Okay. Why is that so exciting? Well, those cars didn't have to stop to get through that intersection. What is one of the biggest energy consumers of our vehicle? It's the fact that you have to accelerate that mass, 3,000 to 4,000 pounds, and get it up to a speed, and then you stop it again. That's why hybrids came about, was to try to grab that kinetic energy and store it for the next time you accelerate. If suddenly you don't have to stop because you've guaranteed a space-time path through that intersection, the whole nature of the automobile changes. You can begin to think about ways of creating and storing electricity on board the vehicle that do not directly always have to deal with those extreme transients that are characterized by what the internal combustion engine does. So we think this mobility internet is going to give us new ways of moving around and interacting, which is very, very important. Now, electric charging and smart grids is another important part of this opportunity. I think we all know that there's a peaking phenomenon in how we use electricity throughout the day, and there's a seasonality. So this is summer and winter days being compared. Today's grids are unsophisticated in how they do metering. They have inflexible pricing structures. They tend to be centralized with no really good ways to store electricity. And the challenge with a lot of the renewable sources of electricity is they're intermittent, like the wind and the sun. As a result, they're not very friendly to really stimulating the use of renewables, and they don't use a lot of information technology. There's a lot of interest in smart grids now for smart meters and dynamic pricing and decentralized generation and new ways of thinking about storing electricity, and that will help us take more advantage of wind and solar and lets us utilize digital networking and large-scale computational backends to really use our energy much more efficiently and price for it appropriately. So really what we've combined then is this new DNA, electrically driven and connected, with the mobility internet and with smart grids and renewable energy to try to bring about the transformation that leads me to conclude nothing really needs to be invented to solve the challenges we're concerned about. What we need to do is find the organizational mechanisms and the collective will to compete against a 100-year-old solution that has enormous scale and enormous inertia. But we can indeed do that, and I'm going to argue how. Now, this is a vehicle concept called Autonomy, and it's going to then take us back to that first video clip. In 2002, we showed this vehicle for the first time, and it was based on the concept of wheel motors. So electric motor in this wheel. This little patch where this tire touches the ground is critically important because you're controlling torque and traction and steering and braking, and then the chassis dynamics. And the vision on this vehicle was to put the energy storage and electric generating capability in that skateboard-like chassis, and then dock the body onto the car like you dock a laptop on a docking station to give you a lot of interchangeability. We got very enamored by this skateboard chassis. We said, wow, that can really change things where I can give the feel of the car through software. At the same time, Segway came out. I said, isn't that interesting? Segway's interested in wheel motors too, but they only have 2 wheels. We said, well, why 4 wheels if you can do it with 2? I mean, Einstein said the best design is the simplest one that works. So we got talking to Segway, and this is what then began to transpire. Could we take the balancing concept, and the engineers went to Cracker Barrel and bought a rocking gliding chair and mounted it on a Segway chassis, and then we got thinking, what might these look like? And we started thinking then, how might they interact with the city? And then notice in this animation how these vehicles, we call them Puma, are moving pretty good. The cars are stuck in traffic. Notice the close headways, and these are driven autonomously. Now, I have a separate lane for these Pumas right now. I think in the future, the vehicle that might need to earn a separate lane is the car, because we've got plenty of roadway space. Now, this Puma is going to weigh about 700 pounds for 2 people. Think about it as a seat on a bus. A bus typically has 32 of those seats for 64 people. 32 Pumas weigh less than a bus. So it's got an energy efficiency advantage. 32 Pumas will cost less than a bus. It has a cost advantage. And we then simulated the movement of Pumas platooned with their headways through the Lincoln Tunnel. 32 Pumas will move more people per hour through the Lincoln Tunnel than platoon buses. So this is transformational, not just in terms of letting me go where I want to, when I want to, dramatically more energy efficient. It's transformational because it could extrapolate to everybody having that opportunity. Now, what might these things look like? They're almost biological in nature. And notice that one pulled up and detected a pedestrian, and when it detected the pedestrian, it bowed and said, excuse me, and gestured politely to the pedestrian. Notice the design bandwidth that we have. These are pretty exciting designs. In fact, I think this is something you're going to want to wear rather than drive. I think it's something you're going to want to park in your closet rather than park it in your garage. 35-mile range, 35 miles an hour, and you might say, are they safe? Well, that's where the vehicle-to-vehicle communications comes in. If you've ever been in a busy subway station, you realize we don't run into each other when we're walking fast. We bob and weave and avoid each other. Bees do it in nature, and birds do it in nature. So if you have a vehicle that doesn't crash, and you have one that can balance and be almost lifelike and biological, could this change the game with respect to how we move around and interact in cities? And that's what we think is possible. And it gives us a chance to go back and make the auto industry or the personal mobility industry a fashion industry and something that really appeals to the things that people are really desiring. But the story gets even more interesting. Affordability. This is AAA's estimate of the average cost per mile for owning a mid-sized car, 55 cents a mile. AAA didn't factor in parking and road tolls, which could be a major part of what goes on in the city. A typical car is 3,000 to 4,000 pounds of material. These Pumas are going to be about 700 pounds. You can park 5 of them in the space that you park a typical car in, so the parking costs go down dramatically. Insurance, they don't crash. So you talk about someone sweating bullets if this comes true. What about the car insurance industry? What are they insuring against? Well, not crashes any longer. Well, what if it's stolen? Well, OnStar can recover stolen cars today. So suddenly insurance costs go down. Electricity. The volt is going to cost about 2 cents per mile energy costs. Gasoline at $3 a gallon with the volt will be about 13 cents a mile. So you're even at a volt-sized vehicle getting the energy cost to move something around that's a third to fourth the mass of the volt's going to be trivial. And then the other components, very importantly, parking. So we're estimating 1/4 to 1/5 the total cost per mile to own this. So from an equality of access perspective, you really have something that can be transformational. So what's the whole point? The whole is more than the sum of the parts, without question. We're converging these ideas. We're transforming personal mobility with a lot of positives, and very importantly, we're driven to enhance our freedom and sustain our mobility and sustain economic growth and prosperity. So that's one message I want to leave with you, and I've got a few more minutes because I really want to get into one more module of this talk, because I've sensed something out there that is concerning me, and that's a tendency for a lot of people to think there's just one silver bullet answer out there. So you might hear me saying this Puma is going to solve world hunger on all these issues. That's not what I'm trying to say. In fact, I think getting the question right is the most important part of any scientist or researcher's job. What is the question? I've concluded the questions we're trying to address around freedom and sustainability are and questions, not or questions. In my role representing GM on these subjects for many years, I was also oftentimes faced with, come on, Larry, what is it? Make up your mind. Is it biofuels or electric vehicles? Is it batteries or fuel cells or solar or wind? Should we have plug-in hybrids or extended range electric vehicles? If you have biomass, should you make ethanol out of it, or should you make butanol or electricity or hydrogen? And it goes on. How about diesel engines or gasoline engines or hybrids or mechanically or electrically driven? Battery swapping or rapid recharging? Should we use our natural gas to make hydrogen, or should we use it to generate electricity? It seems like a lot of people get fixated on the or, and I think the power is in the and I want to make an argument for that. First of all, the scale of the challenge that we're talking about is enormous. I mentioned earlier, 850 million vehicles in the world. You're not going to shift that overnight. I also talked about diverse consumer needs. And excitingly, there's a portfolio of promising solutions. Progress is being made on all of these fronts, and there's synergy in the total solution. The power of and suggests that to improve efficiency and reduce emissions and displace petroleum, we're going to have a wide portfolio of solutions involving energy diversity and automotive technology. And this is where the scale question becomes very interesting. This happens to just simply be a plot of vehicle miles traveled. The solid line is fact. The hard dotted line is a DOE forecast, and the smaller dotted line is an extrapolation. So first of all, if you wondered, did the recent recession really play out in how people drive? Absolutely. Look at how linear this was, and boom, unprecedented. But DOE is anticipating we'll get back on trend, and vehicle miles are going to grow, and auto ownership, which is called the car park, is going to grow. Along with that, they've put together a forecast. If we keep the fuel economy of the U.S. fleet where it is today, how much petroleum will we consume, and then almost how much CO2 is generated. And you can see there's quite a bit of growth there. And DOE has concluded that with the new fuel economy standards and improvements in a shift of mix as gasoline prices go up and we shift from bigger vehicles to smaller vehicles, from trucks to cars, that we'll be able to offset that growth. So the forecast of DOE on petroleum consumption is flat, while we're still going to be driving more miles and owning more cars. If we want to reduce 80% our CO2 from 1990 levels by 2050, this is where we're going to have to get to. So DOE has factored in the most optimistic assumptions you can make about mix shift and other things to just stay flat. So how are we going to get down to that point? I want to share some scenarios with you. The first point I want to make, to get to that point would mean the fleet is going to have to average 240 miles a gallon. And the regulations have gone from 28-something up into the 35, maybe to the 40-something. You're not going to get it all with efficiency. You're going to get some of it, and the market will drive us there, but you won't get it all. So we have to get some alternative energy. Let's start with biomass. These are kind of busy graphs, so bear with me. This is petroleum consumption. This is greenhouse gas emissions. This is 2030. Sandia National Laboratory has done a study to suggest that there's enough land and water, enough capital to be deployed, and other things to create enough biomass to displace this amount of petroleum. This then is an extrapolation that says we'll keep improving agricultural technology and biofuel technology, and we estimate a potential for biomass to solve the problem. And it does quite a bit of petroleum displacing, but it doesn't by itself solve greenhouse gases. So if someone is telling you we just have to move with the biomass industry and our problems are solved, it's not going to take us all the way there. Electricity. How many of you know exactly how the electricity is made that comes to your house? Most people don't know that. You want it to be affordable, safe, and reliable. Look at the diversity of how electricity is made in the United States. From West Virginia, obviously being very coal dependent, to California having a mix that is less coal dependent. Now, California's CO2 mix is about 2/3 the amount per unit of electricity as the nation. And we ask ourselves, what if we could get to plug-in electric vehicles under the assumption that our grid becomes as clean as California, recognizing it's not there now and some things are going to have to happen to do that. And yes, electricity can displace a lot of petroleum. But remember that consumer map I showed you, electric cars won't satisfy everybody. So this is just a calculation that said 60% of the miles would be captured by electricity. But notice, even at California cleanliness, it doesn't deal with the CO2 challenge. Next is hydrogen and fuel cells. Hydrogen can be made from natural gas. Natural gas is 1 carbon, 4 hydrogens. You strip the hydrogen off the carbon. It's a mature process. In fact, there's so much hydrogen being produced today to make gasoline that you could fuel 200 million fuel cell vehicles in the world just with the hydrogen that's produced to blend with gasoline to make gasoline clean enough for our emission systems. If you use that natural gas, boy, you can displace petroleum, but you still have some CO2 concerns. Now this one gets a little more interesting. What if you made the hydrogen from biomass? Now, interesting about biomass, you can use the biomass to make ethanol. You can use it to burn at a power plant to make electricity. And by the way, the utilities are really driving up the demand for that biomass as they seek to meet the renewable energy standards. And you can make hydrogen from it. If you have an acre of biomass, and you could do one of those 3 things, which one would take you the farthest? Hydrogen with a fuel cell, electricity at a power plant to a battery to an electric car, or make ethanol out of it and burn it in an internal combustion engine. Turns out the hydrogen fuel cell wins that debate. You can make a lot of hydrogen from the biomass, but the beautiful thing about biomass is whether you make alcohol or whether you burn it for electricity or make hydrogen, the supply chain is almost identical all the way up to the very last step. I would contend this is a robust thing to pursue. Now, a lot of debate about unanticipated consequences. I respect that debate. We're going to have to understand it. But I think this is a robust play. But my real message is all of them, because the market should sort this out. All of these are promising opportunities, and we need to drive them to their market tipping point and then let the market scale. And my intuition tells me we're going to see a mixture, and that's the power of and. I've talked about this slide already. You also want to have an and solution because different customers have different needs. This next and is extremely important, and that's synergy. A lot of people will think about wind competing with solar, competing with biomass, transportation solutions competing with stationary solutions. What we're finding is when you look at it all as an integrated system, there's some great positive synergies. Hydrogen can be made from electricity, electricity from hydrogen. That's interesting. I made the point on biomass already. Lower cost lithium-ion power batteries, enhanced hybrids, but also fuel cells. And the last point, electricity stored and created on board vehicles for transportation stationary. This is one of the most important points I'm making tonight. When you model a community and ask how much sun is shining on that community and how much wind is blowing in that community and how much biomass is that community capable of creating, how much movement in terms of transportation is that community demand, and how much stationary is needed for lighting and heating and air conditioning. When you optimize all of that as an integrated system, you get a much lower cost than if you say, I'm only going to use wind, or I'm only going to use solar, or I'm only going to use bio. Now, when you do that optimization for some communities, you're going to find out they have more renewable than they need. Other communities are going to need more than they can create. What if we found a way to move the surpluses to where the shortages are? Would we conceive of a world where renewables are going to be a much bigger part of the answer than a lot of the forecasters predict? I think we will. And I think this distributed community-based perspective on renewables is absolutely transformational if we approach it from a systems perspective. So a full portfolio of solutions is called for as we migrate from more carbon-intensive fuels to less carbon-intensive fuels. You say, well, how are we going to get there? A lot of people want to focus on the year 2050, and then they get obsessed with how much is the new infrastructure going to cost in total. I want to encourage you, as you weigh in on these debates, focus on a different point in time, which is much more near term, and that's the market tipping point. What's the market tipping point? That's that point where the value the customer sees is greater than the price they pay, so they want it, and the price that a firm can charge is greater than the cost they incur, so they want to build it. And when you get that magic of supply and demand, you get a growth dynamic that's going to be very nonlinear. And I would contend, whether you're talking about hydrogen and fuel cells or batteries and plug-ins or biomass, that we're within 5 years to 10 years of these market tipping points. We're talking about scaling these technologies to about 1 million a year in an industry that builds 70 million cars a year. And you need 3 commercial learning cycles with real manufacturers and suppliers making real products to learn the manufacturing processes to get them to tip. But they can tip. We need a collective will to do it. Energy policy must be a total system strategy. And unfortunately, I've lived through a period of time, 2 administrations as a senior person, part of this, the Clinton, Gore, and Bush. So I work closely with Department of Energy. I work closely with other departments. There tends to be a tendency to politicize this and try to pick the winner. No one's smart enough to do what the market can do. And we have to stay focused on a portfolio of options. So I said the most important thing to do is figure out what's the question. And I think the question is, how can we work together with a collective will to enable all promising technology solutions to quickly and efficiently reach market tipping points and deliver their optimal interdependent value to consumers in the world? That's the question. And questions are really important. I was talking to my wife the other night. She's a little bit younger than me, and I asked her one of these questions. In retrospect, I probably shouldn't ask it. If anything ever happens to me, do you think you're going to get remarried? She says, no, I couldn't remarry anyone. I'd care too much for me. I said, you'd be young, I'd be gone. It just makes sense. She says, okay, I'll think about it. I said, well, if you get remarried, you're going to let this guy have my car. I've got this sports car. That's my pride and joy. And she said, no, I mean, you love that car. I couldn't let him have it. I'd be gone, and the car would be there. It just makes sense you have the car. And she said, okay, I'll think about it. And I said, what about my golf clubs? And she goes, oh, he's left-handed. So, you got to get the question right. I can't overemphasize this. Now, I have to give you a sense that this vision can be realized. It's a lot of fun to be a strategist and a visionary. It really is a lot of fun. But is this possible? And the last chapter of our book, chapter 10, really gets at how are we going to realize the vision? And there's some great lessons from the internet. The internet had its initial conception from the government. DARPA had a role to play. The internet grew rapidly because standards were created. So standards are going to be a big part of this. The internet grew and created a commercial ecosystem where there's companies that did operating systems and companies that did servers and companies that did hardware. It's interesting how the share leader in each of those categories tended not to attack the other category. So there was this codependence in this system that you have to understand. And automobile transportation, the codependence is the car, the energy infrastructure, the roadway infrastructure, and the controls and laws that govern it. So we're talking about a challenge here that involves large-scale codependencies. 250 million automobiles in the United States, 170,000 gasoline stations, 3 trillion miles a year being driven in the U.S. by automobiles. 85% of our personal mobility comes from the automobile in the U.S. It's a wicked problem, and wicked isn't just wicked in the sense of an adjective. It's wicked in the sense of a problem that is nonlinear, it's dynamic, it's stochastic, it's changing. You learn and you get out and try something, and in fact, it never really gets solved, but it just has the hope of being improved. We've tried to learn as much as we can. How do you go at this? You have to have a collective will. I've traveled to a lot of nations around the world, and there are other nations in the United States who are showing an ability to gain that collective will, a much better alignment between their policies and government and their industries and their technology creators and the early commercialization of these technologies. You have to have a competitive, comprehensive roadmap. It's an integrated roadmap, not just a roadmap for batteries and a roadmap for fuel cells or a roadmap for renewable energy, all of that taken together. You have to focus on these market footholds. Try it out. So you don't go to cars that don't crash in one step. You try out adaptive cruise control first, and then you try lane keeping, and then you try forward collision warning, and then you try 2 or 3 together. Then you do autonomous driving on the freeway. Then you do virtual valet where your car can park itself, and next thing you know, you're getting close to the end. Make sure you keep a portfolio of options in play. The market will sort the scaling mechanism out. That's where the big capital gets deployed, is when this thing scales. And we have to keep enough options in play right now to make sure when that scaling happens, the right things are being scaled. You have to get standards in place to enable these positive network externalities. Certainly if I was the only one that had a phone, it's not worth much, but if you had one, I can call you, but the next person who got a phone can call both of us. This thing goes up geometrically, and that's great. Then you have to capture the imagination and desire of the players, especially consumers. You have to demonstrate. You have to find very good ways to demonstrate and demonstrate affordably. I have a very good friend named Roger Martin. He's the dean of the Rutland School of Management, and this is what he had to say about wicked problems. They call for us to harness all of the creativity and knowledge at our disposal by working to enable shared understanding and commitment. We have the collective power to shape our world for the better. Whether we choose to fight one another or work together to confront opportunities and threats, our fate and commonwealth are in our hands. And I'm seeing that playing out here in the United States, and I'm deeply troubled by it because I think we're having too much of a tendency to fight each other rather than getting at this collective will and doing what's within our grasp. And one of the very exciting aspects of visiting Columbia today is you have leadership here that I think understands this, and you're creating the educational mechanisms and the relationships with industry and with governments around the world to do something about it, and I appreciate that very much. So I'm going to stop there in my talk. Because of my hearing, Sarah is going to help me with Q&A if I don't hear you, and I think we've got 20 minutes or so for Q&A. Thank you.
with such an autonomous system for, I guess, cities to work together, yet still the existence of a large market and demand, how do you factor in like performance automobiles and recreational driving?
This was for recreational driving?
Performance automobiles and recreational driving.
Yeah, yeah, automobiles for recreational driving is really something that's important. While I'm passionate about autonomous driving, I think the first step is going to be the car can drive itself when you want it to, and then you can drive it as well and enjoy it. It was interesting when you look at the history of horses, everybody was riding horses because they needed to. That was part of how the economy worked, and then along comes the horseless carriage. Then horseback riding became more of a sport. And so people found a way to still enjoy the things they were passionate about the technology. And it was kind of fun. We had a group of really relatively young automotive designers from the College of Creative Studies, which is a source of automotive design talent. So they were freshmen and sophomores in college. We had them in for the summer, and we showed them this technology vision, and we asked them to design ideas, and many of them went after the point that you're making, recreational. They had some great ideas. One was a person who would be in a car autonomously driving safely and doing everything great, but inside the car was a simulator, and he was a NASCAR driver inside the simulator, working up a sweat on the way to work, having the greatest time possible. So I think there's ways to get at some of that. Thank you.
You were talking about these different technologies, the lithium cell or fuel cells and so on, but when you were designing the Volt, you decided to go for the lithium-ion battery over the fuel cell. What was, and it seemed in your talk that there were a lot of appealing things about the fuel cell. I'm wondering why you chose a lithium battery rather than the...
We're doing both. We had at the same time we developed the Volt, we developed the 115 Chevrolet Equinoxes to full automotive engineered standards so that they could operate on real roads. I went through that slide pretty fast, but a Chevrolet Equinox is a mid-size crossover sport utility vehicle. And we put our fuel cell propulsion system in place of the engine, and then we put hydrogen storage on board, and then we actually did the final safety test in front of the head of NHTSA, the National Highway Transportation Safety Administration, 50 miles an hour into the back corner where the tanks are, to prove it would be safe. And now we've had these out on public roads in the United States, in Germany, and in Japan, and in very soon China. Part of the challenge we have with making the same play that we did with the Volt with fuel cells is the infrastructure. There's no question about that. We could bring the Volt out and know people could find a place to plug it in. We couldn't launch fuel cell volume yet until we had more confidence the hydrogen infrastructure would be there. But I can assure you it takes only about 40 stations strategically placed in Los Angeles to cover most of the driving requirements of people who want a fuel cell vehicle in Los Angeles. You don't need thousands and thousands and thousands of stations to get started. So no one's given up on that. It's just a matter of when is the right time to make the next move. Our next fuel cell propulsion system really sets up that dynamic to truly compete with the internal combustion engine over about 2 or 3 commercial learning cycles. Go ahead. Yes.
You seem to have some very interesting, there seem to be amazing ideas about the new design of cars, particularly in the urban environment. But I was wondering, what do you think, and also with the consumption of energy, but what do you think about the future of the car in long-distance travel, and also its consumption of space in highways and in literal design?
Really a great question, because a lot of people are wondering, should we move between Detroit and Chicago, for example, with a new high-speed rail system, or should we do that in our car on the interstate? A lot of people fly from Detroit to Chicago. One interesting idea with these Pumas is it's your personal pod, and if you wanted to go from, let's say, New York City to Washington, D.C., you pull up on your pod and you interface with another chassis, a flatbed truck-like chassis with a much higher speed and greater range, and you interface and lock on. So I'm still in my personal pod. This is back to the bus seat example, but now I've got this boost of power and range with this flatbed truck. Now, how might that work? Well, I think that flatbed could run autonomously on the interstate system right now with short headways, because of the controls we have, and real-time information will marry you up with a bunch of other people who need to go to Washington, D.C. at about the same time. And now we're moving down the interstate with these autonomously controlled vehicles moving a lot more people. So that's one idea, but that's not the only solution. What I like about your question is you realize personal mobility isn't just in a city. It's all kinds of personal mobility. And mobility is a good thing. It drives economic growth, but we have to do it sustainably. Next.
Hi, thank you very much for your presentation. I'm actually finishing up my dissertation now on the clean tech movement in the auto industry. And I think you're right on talking about the codependency of many different types of organizations. And that's what I've witnessed with plug-in vehicles in particular.
Yeah.
And I just want to say the perspective you bring is very unique because I go to a lot of industry conferences, hear a lot of automakers speak, a lot of entrepreneurial companies, utilities, nonprofits, and it seems that everyone has their own particular niche that they would like to promote. And my question is, because I think your perspective is so necessary at this juncture, what is next for you?
What is next for me?
And because I would love to see you get involved and promote the and.
I appreciate the question because yeah, I'm going to get a little personal now. When you spend 40 years with a company, by the way, General Motors paid for my education. The day I turned 18, I went to work for GM at a school called General Motors Institute. It's now called Kettering University. And I would work 6 weeks. I worked in research, and then I went to school 6 weeks and did that for 4 years and became a mechanical engineer. Then they were generous enough to pay for my master's in public policy. And then when I went to Berkeley for my doctorate, they allowed me to continue my employment and work in the summers, even paid my travel back and forth. So I always wanted to be a college professor. That's why I went to get a doctorate, and I figured when I finished at Berkeley, I would do just that. But something told me I had to pay this company back. I didn't legally have to, but ethically, I just felt they really supported me. So my life plan was work 3 years at GM and then go to work at a university. And never happened. Because each time I started thinking about something different, GM was one step in front of me in managing my career. One of the most transformational experiences I had was about 10 years into my career, GM put me to work in an assembly plant, implementing a product that we were developing. And believe me, there was nothing more exciting for a researcher to suddenly realize that a decision you make right now, feedback loop is measured in minutes because assembly plants make a car a minute. And I had 2 plants, and we were trying to improve quality, and I'd say, do this, and next thing you know, someone would do it, and sure enough, either right or wrong, you knew within a few minutes. That was so energizing. And so I worked in the operating part of GM for 10 years, but then that really shaped me as a researcher because I began to understand how the world works. So that's background. But I do want to be part of a university. I want to be affiliated with students because I think there's no greater acid test for these kinds of ideas than young creative minds. I want to be able to write more. I was really stimulated by the process of doing this book with MIT Press. But I also want to go where the capital is, because for these solutions to scale, capital is going to have to be deployed. And 3 kinds of capital deploying mechanisms. Big incumbent companies with deep pockets, entrepreneurial companies, startups, and then governments have a way to funnel money. And you know, Stefan During is here. Stefan and I have become good friends, and he teaches entrepreneurism and entrepreneurism here at Columbia. And those kinds of things, I think, are going to be very, very important and transformational. So somehow it's going to be a mixture of affiliation with university and doing some advising to big companies and playing in the venture world in some way. I don't know if that'll work, but it'll be fun. Yes?
Very interesting presentation. Thank you. I had a couple of questions, actually. In one of your slides, or it was a video, you had you showed the cars at an intersection, weaving in and out.
Yeah.
I just wondered what place a pedestrian would have in that in trying to cross the street.
This is a great, very, very good question. And it's something we're going to have to actually address.
What? I'm sorry.
It's a very important question.
Yeah.
It's something we will be addressing. We believe it's not just vehicles that'll be moving around, but bicyclists and pedestrians.
But would the pedestrian have to wear one of these sensors or something? And what about a little child?
You know, quite honestly, pedestrians many of us are doing that today as we carry our cell phones and iPods around. They have GPS and they have wireless communication. And those will be interesting. Another option is to have the sensor at the street when you go to cross and you grab it and you move across the street. But for sure, interfacing those kinds of vehicles with pedestrians and bikes. The real advantage, though, the mass is much smaller. So 700 pounds versus 4,000 pounds.
Yeah, I like
and the
that.
speeds will be lower. And so the physics
Yeah.
of the vulnerable players are going to change
And
substantially.
the other question I had was about biofuels. Are you talking about corn-based?
No.
Okay.
Let me talk about two specific technologies because we've invested in them. One of them is a company called Cascada. Cascada takes municipal waste, garbage, old tires, you name it. They grind it up and they burn it. And instead of letting the gas go into the atmosphere, they flow it through some membranes and they feed it to these little bugs, microorganisms. And when the organisms eat the gas, they excrete ethanol. You could have a different type of organism that excretes hydrogen. So this is taking garbage and turning it into waste. There's a second company called Moscoma, and what they've observed is there are a lot of crops in the U.S. when the country was first settled that never required irrigation, fertilizers, or pesticides, genetic strains of prairie grass. The problem with that for ethanol is it's been a two-step process. Starch to sugar, sugar to alcohol. And they've created an enzyme that can do that in one step and reduce the investment significantly. So both of those are non-food based. Yes, we have to worry about the land use implications, we have to worry
Yeah.
about the water implications, but we think they hold great promise.
Thank you.
Thank you.
Thanks so much for speaking to us today.
Thank
I am especially impressed at how you see this as a system. I used to be an urban planner working for New York City and was involved for some while with trying to get congestion pricing, which I guess, following your lecture, I see now kind of as a foothold technique to try to get people to understand the externalities of congestion. And, I got pretty frustrated because obviously it didn't pass, and that was the point at which I thought, well, I should enroll in business school and learn about how the other side tries to go about it. But even during the process, I wondered, we talked to so many stakeholders, what was the automotive industry's thoughts about this? And like the vehicle-to-vehicle sensing, which could, be retrofitted into the 800 million vehicles already, in the world. Had you thought of some kind of foothold technology that could start making people more aware of this?
Yeah. We realized that if Chevrolets just spoke with Chevrolets, that's not going to really realize the societal benefits. Chevrolets are going to have to speak with Toyotas, and Toyotas with Fords, and Fords with Volkswagens. And as such, we've been working with the federal government, the National Highway Transportation Safety Administration, and others to try to find a way to work together, share the data, do the necessary testing, and begin to move forward. As I mentioned before, I think these liability issues are going to really be an important challenge. Let me give you a scenario, one that haunts me, quite honestly. Let's say you bought a brand new Corvette, and it was stolen. And the person who stole it drove it through a neighborhood irresponsibly at a high speed and hit someone and harmed them seriously, and they wanted to sue. It wouldn't be fair to sue you. I mean, geez, your car was stolen, but you didn't cause that to happen. Would it be fair to sue the person who stole the car? Well, probably, but that person doesn't have very deep pockets, so that's not going to help. The next question they're going to ask is, Chevrolet, how could you possibly let that car go faster than 25 miles an hour? The car knew where it was, the digital map knew the speed limit at that location, and the car knew how fast it was going. Why did you let that happen? And I think it's a fair question, and that's why we're going to need mechanisms of social engagement and other things to really realize this full potential. As a technologist, it can be done. There's all kinds of things I can do to take control away from you and your car to allow you to drive more responsibly and safer. But what I really stay encouraged by is how quickly the U.S. adjusted to the concerns about secondhand smoke. Phenomenal how fast that changed our behaviors once it was clear that one person smoking had an externality that harmed another person. And so I think we'll find a way through it. Okay.
Thank you very much for the depiction of the mobility of the future. And because of your long involvement with General Motors, I sort of feel pushed into ask you a question. Why did General Motors lose 25 years since its first time around that it actually had an electric car? You know, that famous thing about who kills electric car.
Oh, yeah. It's a great question, and I've thought a lot about that because of my role in trying to help bring change about in General Motors. And, you know, a lot of the really great companies in the history of the world were first created by individuals. You look at the ones we're most familiar with now, Gates, Jobs, those kinds of folks. And then these companies become big and complicated, and they begin to create processes and mechanisms to be managed. And eventually, financial objectives get set by corporations and short-term objectives, but also legacies get established. And in the case of General Motors, after World War II, the U.S. auto industry grew very, very fast, very large, but very unproductively. And it was an oligopoly, 3 companies competing. So you had huge market shares for each one. And then in the 70s, a few things happened. Fuel economy regulations, which were necessary, environmental regulations, which were necessary, safety regulations, which were necessary, required a dramatic amount of money to be spent to change automotive designs, and new competitors came in, and market share dropped. Suddenly, these companies were faced with way more capacity than their market share, capacity that had grown grossly non-productive, and designs that had way more parts than were needed, and union agreements and commitments to retirees and employees that created huge legacy exposures. And so General Motors got into a situation in the early 90s where, quite honestly, the company probably should have went bankrupt then. And our leadership, I think, kept the company afloat for another 17 years, just getting by the skin of our teeth year by year. But we were making great progress in dealing with that productivity gap and reducing that capacity and getting competitive. And then auto industry volumes went from 17 million a year to below 10 in about a 3-month period. It's a very cash-consuming industry when that happens, and we didn't make it. And we weren't able to sustain our bets on some of this technology because all these other voices were competing for that money. Everybody was trying to get their slice of the pie. And I think we were serving a lot of players other than the one that we really needed to serve, which was the customer. And I think that's, in essence, a short summary of what happened to us. And as we tried to stick with some of these technologies like EV1, it was just too expensive to try to bring that maturing process about all on our own. Generation 1, Generation 2, Generation 3 is a very expensive game to play with capital-intensive technology like batteries or new kinds of motors and things. I hope that got at your question, but that's kind of a history of what's happening.
If I allowed a follow-up, would it not happen now that in order to achieve these nice goals, which I'm all for it, that we will have actually to transfer the production lines to China?
Well, the one thing that I have studied carefully are industries that have gone through transformation. And I've asked myself a question: what happens to the big incumbent players in industries that are confront transformation? Let's take the photography industry, print, film to digital. Oh boy, that was a transformation. And let's take the communications industry, wired phones to cell phones. That was a transformation. And mainframe computers to laptops to handheld devices. And when you study those industries, you realize big incumbents rarely come out the other end of a transformation as the big player. It's really, really interesting. IBM is an example, but you can't find too many more. And I suspect there'll be a new ecosystem, a new commercial ecosystem that'll be created around this vision that I talked about. And maybe this is Google meets Cisco meets GE, and maybe they're the ones that bring out the transformational products as opposed to the traditional auto companies. I'm not saying that will happen. And maybe it's going to happen in a country other than the United States, one that has a more enlightened industrial policy and one that, very, very importantly, like China, that we can't repeat the sustainability challenges that we created as we went through our first 100 years with the automobile. So I can't tell you exactly what's going to happen. I will tell you this. as a strategist, the golden rule is do unto yourself before others do unto you. You better find a way to attack your own strongholds because others are going to attack them. And if you don't think you're vulnerable, you're mistaken. Things are moving so fast. As I told you at the beginning, the toughest thing to do as a boxer is pick up your teeth with your boxing gloves. And your teeth are going to get knocked out if you're not paying attention. So I hope that helps. I'm off on a tangent now, Sarah. But what do you think? One more?
Either one more or we have a reception outside. So
Okay, why don't we take one more and then, wait, two more. We have two people who are courageous enough to go to the microphone. Okay, go ahead.
So my memory might be a little rusty, but I think in 2008, GM had spent a little over $8 billion on its R&D program. And given the shortage of capital right now, how do you prioritize your R&D budget? And do you think it's more prudent to outsource a larger portion of the vehicle technologies to auto parts makers so that you can focus on more value-added, more, I guess, core set of technologies?
Yeah. Let me address that as I'm not a GM employee any longer, so if there's anyone here from the media or anything, I don't want this to be answered as a GM answer. I'm answering it as a Larry Burns answer, just to make that clear. The $8 billion you referred to on R&D, that is the way that the financial rules, when you write an annual report, require you to report all of your engineering spending. So that $8 billion included advanced technology, but it also included the money you would spend to do the next Chevrolet Malibu or the money you would spend to do the next Chevrolet Corvette. So that's a lot of that money was simply being spent to engineer the next generation of a product that's already in the market. So the R&D advanced technology spending wasn't anywhere near $8 billion. It was significant, and it was a big budget, and I had the privilege of managing that budget, but it wasn't $8 billion. So the new GM now is in an auto industry that has had a pretty big shock. I mean, the global industry dropped off, and the really great thing that happened, though, as tough as it was, when it became very clear that the old GM was about to spend their last dollar, and for any of you that want to be an entrepreneur and have your business, never, never, never run out of cash. As soon as you spend that last dollar, you lose all of your options. Don't let that happen. And we found ourselves at the end of December of last year on the brink of having to spend our last dollar. And because the global economy had taken such a hit, there was no sources of credit. No one was going to lend us money. And the U.S. government and the Canadian government stepped forward with $58 billion. You don't get do-overs very often in life. You don't get second chances very often. And the U.S. government, Canadian government gave General Motors a second chance. And I can assure you the leadership team in place at General Motors right now is going to not blow it. No, they're going to have to make some very important progress on the viability plan that the company committed to get the loan. They're going to have to take this company public at the appropriate time and generate equity that can begin to pay back that loan. I can tell you this also, the new GM products are phenomenal. They're very, very good. And at the same time, we've sustained our business in China. We're a 50-50 joint venture with Shanghai Automotive, and that business is growing very, very fast. And you probably read even just today that General Motors decided to keep Opel, the German-based company, as part of the company. So the leaders of GM will sort through this and make those prioritization decisions. But keep in mind, it's not just GM that's in this ecosystem. It's the energy industry. It's the communications industry. It's other forms of mobility. China now has a electric scooter volume in China has reached 60 million electric scooters. That is really saying something. The growth of the electric scooter industry is very, very fast. It's not happening in the traditional auto business. All right, one more question, then we'll go to the reception.
Yeah, hi, my name is John Dulek. I'm a dual degree student here between public policy and urban policy. And as a former engineer, this kind of stuff very excites me. I think it has a lot of potential to solve a lot of solutions, particularly within the automobile industry. But as a policy student, I'm not so sure how far into it I agree, or buy into it, I guess you could say. And so my question for you, as you said, as Larry Burns and not as a GM representative, is that fixing some of the economic and technological issues is an important task in the auto industry, but there's also the social and political
Absolutely.
realms that deal with things like the $200 billion infrastructure price tag we have every year, or the $1 trillion infrastructure backlog we have in this country, not to mention that, you know, American adults are overweight because they don't walk enough. And so where does the auto industry start to, if they're going to address a comprehensive approach to travel, which means accessibility and affordability and safety? When do they start to look beyond the automobile industry and to say that maybe people don't need to drive certain places? Maybe there needs to be a shift demographically in how we look at travel in this country.
Absolutely. I think those responsibilities are enormously important. I think it's great you're here at Columbia because Columbia sees that as an interconnected system. I had the responsibility to go to Washington, D.C. a lot the last couple of years as we work through these challenges, and I met with senators and representatives and met with their staff members, and the ones I found most impressive were the ones that had a comprehensive understanding of not just policy, but of economics, of business, and at least enough understanding of technology to know whether something really has merit or not, because there's a lot of noise out there. And General Motors makes a private good that you purchase, but it operates in a public system of roads, and it's also part of a set of concerns of externalities, and you can't run from that. You have to be engaged, and you have to be part of the solution. The good news is, if you get it right, there's going to be money to be made, and shareholders are going to benefit from that. I don't think you can decouple the two. That's Larry Burns personally talking. And we're going to have to find the collective will and find new private partner organizational mechanisms, private-public organizational mechanism partnerships to move forward, because I see it in other nations. I was in Singapore in July for a week, and you want to see something aligned. Look at the objectives of the Singapore government, aligned with their technology institutes, aligned with the venture initiatives in the country, aligned with the goal of creating new businesses and new jobs. It's beautiful. And we tend not to grasp that as well here in the United States, and we're going to have to. Okay? So Sarah, I'll turn it back to you. Thanks, everybody.